computer. Okay, I'm recording. All right, so let's go here. And go to this. Okay, let me check first of all to see if the course location is on this web page. Let's go to the, it says courseworks, but it's not really. Oh yeah, actually I just saw it, it was right there. Okay, I don't want to go to courseworks, hang on. See, yeah, 328 Prentice Hall at 632 West 125th Street. Okay, that's where you go. Okay, so let's go ahead and look at the syllabus here. All right, that's wrong. Oh, I'm looking at the wrong class. No, that's right. No, I'm looking at the wrong class. That was Seth's class. Yeah, I'm doing this class this year. No wonder. Boy, this is really getting off to a great start, guys. Okay. But I think that also had it. Yeah, it says, yeah, 328 Prentice Hall, 632 West 125th Street. Okay, that's cool. Okay. Yeah, that's what it should do. So here we talk about the class. There's the course syllabus. Okay. Week 2, we're going to be doing this. Like, I'll turn that into a link, and all the patches that I make today, I'm going to be putting there so you can download it and everything like that. Okay. But the thing we want to do right now is not look at my email, is look at these guys. Okay. So I did a little search trying to look for some decent kind of data sonifications, and one of the places that has done a lot of sonification work is NASA. Okay, but unfortunately, well, I'm going to play you some, and you'll see what I'm going to talk about here in a second. Okay, let's see. This is the first one. Okay, I think this is, yeah. Is that the one I want to do? Yeah, this is basically, and I'll put links to these in the thing. I'm not going to play the whole things here, but this is an example. What they're doing is they're looking at features in the galaxy, and they're looking at X-ray emissions and things like that, and they basically translate those into various kind of musical parameters, and they come up with stuff like this. Okay.
The center of our Milky Way galaxy is too distant for us to visit in person.
Okay, let me run this ahead a little bit. Okay, right here.
Right across the image. The sounds represent the position and brightness of the sources detected by NASA's Chandra X-ray Observatory, Hubble Space Telescope, and Spitzer Space Telescope. The light of objects located toward the top of the image are heard as higher pitches, while the intensity of the light controls the volume. Each type of light reveals different phenomena in this region, which is roughly 400 light years across, at a distance of about 20.
Okay, so first of all, sorry about the little glitches. I've been having those today. The internet has not been happy out here. So there's stuff like that, you know, and then you can encounter things like this. And they're very nice. They're very pretty, you know. I mean, but one of the things that this doesn't do, I mean, as kind of a fun artistic experiment, which is one thing you can do with data sonification. These are kind of fun, but they also don't really reveal much about the data. You know, they're not. You know, one of the things that I think data sonification can do is actually help us to understand. In fact, next week, the example that we're going to be doing, I'm going to be showing something that kind of does that. Okay, but there's also examples like this, which is this is typical of a DNA sonification. I didn't even read how they did it, but you know you're going to get a sense of it here. What they're doing is they're mapping the three base pair codons onto a particular set of pitches, equal tempered pitches in this case, so that every time you're coding for a particular amino acid, you're going to get a particular note, which is all well and good. And you are possibly hearing something interesting here. Some of the repeating sequences, those are things that might have some kind of experimental currency or something like that, But the problem with this is, this is just one particular part of DNA. DNA is like billions of base pairs, so I'm not sure, it's kind of like looking at the DNA molecule and saying, oh, that's really interesting right there. There's going to have to be some other things done. And in fact, some of the things that we get to later in the term when we start talking about machine learning and feature extraction, those are the kinds of operation that can probably do it. Here's another DNA sonification example that's kind of fun. Okay, here we go. Okay, so I'm not sure what the point of this is, but the main melody is DNA sonification, but the piano chords is by the guy who did it. Okay, and apparently this must be like a happy mitochondrion or something like that. I don't know exactly what it is, but that's sort of cute. And I'm going to go now. This is probably the sonification that really nails it. This is what Nicola sent me. Okay, and we're going to watch. This is using, I guess Microsoft even makes well, they've got this Songsmith stuff, but there's actually some data sonification toolkits out there now. And in a way, I guess RTcmix and processing are, but they're more like a generic programming language. Toolkits have a very hefty set of assumptions that come with it. But this is just kind of straightforward sonification, and it's kind of funny. We're going to watch like the first 3 minutes or so. I might skip ahead at one point, okay, but here you go. Okay.
Maybe make it full screen so everyone can read the data.
You want to see it full screen? Okay.
Yeah, I think it's better for reading.
Okay. How's that? Okay.
Pretty good.
Go. This part's kind of goofy, but now, this is where the hammer comes down. Just a second. I'll stop it there, but you get the idea. I mean,
yeah. I wanted to say this is maybe other than the GEMA piece, which is another one that Johannes Kreitler did. So he's a German composer, now professor of composition in Basel. This is maybe his most famous piece.
Really?
It was played at like every big new music festival, including Darmstadt, Donaueschingen, everything.
Really, I had no idea.
Yes.
I did not realize that. Oh my God. Well, one thing to realize is that the dates, I hope you saw it, it was 2009. So that's why like Lehman Brothers just like falls off the earth, you know. I mean, it was not a particularly good year, you know, although God knows what those things would be now. But what I love is just the incredible schmaltzy music behind this just horrifying data. You know, I mean, that data is data and how you treat it is kind of up to you. I mean, bizarre stuff. And kind of in that spirit, I'm going to show you just one more thing. Okay, actually, I have two more things, but this one, I'm going to put this on. This is a long segment. It's about 14 minutes long, and it's actually a pretty interesting critique of data sonification that this guy does. And I'm going to run it ahead to here because this is just one example of sort of what he kind of gets into with this. Okay. So I'm not going to make it full screen. You don't really need to see the whole thing, okay?
And therefore, perhaps it might lend itself better to more complicated data where the signal has picked up a lot of unwanted interference.
Sorry.
So let's say you have to read an incredibly long email from your boss that you have to finish before the big meeting starts.
Yeah, let's not say that, okay?
Interference, like that coming from particle collisions. And that brings us nicely to the Higgs boson, which was measured at the Large Hadron Collider at CERN. The data in question is collected when two proton beams were successfully smashed together, producing an explosion of particle debris and a simultaneous explosion of dilettantes trying to make a name for themselves. Here's a TED Talk given in Geneva by a person from CERN who was involved in trying to sonify this data.
And at this time I became a bit interested. I wondered what an electron would sound like.
So to achieve this, they measured two things, the particles themselves and the amount of energy belonging to each one. But since a collision happens so incredibly quickly, time as we understand it isn't really a factor. So to get around this, they looked at the position of each particle and read them in a clockwise motion to determine the order that we hear them in. I mean, you can already close the book on the idea that this is the sound of the particles at this point, but let's carry on anyway. They then represented the amount of energy contained in each particle using pitch.
If it's high energy, high pitch.
This is the most common sonification technique. When there's more of something, raise the pitch. Anyway, the presenter goes on to assure us of the scientific rigor being used here.
The science is in these arrows. We don't just create a vague relationship between the sonic properties and the physical properties. The relationship has to be exact and rigorous.
Sounds very meticulous. But hold on, there's more.
The art is in where we place these arrows and which parameters we decide to use.
Oh right, so these are just arbitrary decisions. You can map the position of each particle to time and the energy to pitch, or the other way around, it doesn't matter. Anyway, they mapped a few more aspects of the data to sound.
But we wanted to try something a little bit more ambitious with the real data. So we went for a 4 to 6 mapping. It looks a bit messy and complicated.
Yeah, you don't say. God, you're presenting a TED. Could you not tidy that up? Here, look, I'll do it. Anyway, after all this, behold, the sound of the Higgs boson.
That's it.
So now we've quite clearly divided those two things. We don't know if you've done it right, but it was fun trying. So it is completely arbitrary, the sounds you get out, really.
Yeah. So, yeah, that kind of tells it like it is. I really got a kick out of that one. But it's a really interesting video, and the guy, even though he talks very fast, he does get through some interesting critique of a lot of this work. Okay. There's one more I wanted to play, and this is almost pure art. But this goes to last time we talked about possibly like taking like the sounds of whales and resonifying them some way, and we will be looking at techniques that will allow us to do that. But this is a guy who created a piece. It's about a 20-minute long piece based on the sound of his leaky toilet in his apartment, and what he did was record that and then resonify it, and he came up with a thing like this. like I said, I'm not going to play the whole thing, but later on you get stuff happening. It's like this. So it's actually quite a lovely piece. I've really enjoyed listening to it. Like I said, I'm going to put links to this stuff on our webpage for the class from today, so you can check it out too. And interesting, he's using that program Pure Data. That's the one we're not using. That's the one that was written by Miller Puckett after he wrote Max MSP. So I think you can even download the patches. Yeah, somewhere in there. Okay, kind of interesting stuff. Let me stop my screen sharing for just a second again. Okay, so one of the things that, you know, hopefully you kind of got a sense of as you're looking at those videos is that obviously the data, you know, we're going to do things to it in order to turn it into sound, in order to turn it into parameters that can be manifest as music or graphics. You know, I mean, like the Hadron Collider thing, you know, it lasted a billionth of a second. We can't really hear that, you know. Of course, when we do stretch it out and we hear it, it goes, that's about it, which I thought was kind of fun. But we're also, you know, along the way, you know, when we're looking at these instruments, when we're looking at these graphic techniques, we're going to be looking at ways of massaging the data. You know, we're going to be looking at scaling, you know, taking the data and shifting it in terms of its extent. You know, a lot of times the data may go from 0 to 1, and we're going to want it to go to, you know, something that we can hear as frequencies. We're going to be looking at normalizing this data, you know, providing a baseline that somehow has salience musically or graphically. And then, of course, the big thing is what we call mapping, you know, and that's where the what was his name? The Basel professor, Kreisfeld, I forgot.
Kreitler.
Kreitler, yeah. Kreitler.
Yeah.
What he did was he mapped this incredible data onto a very schmaltzy major scale. You know, and that's a decision you make. You know, we're going to talk about how you quantize data, how you can map it onto a whole tone scale or map it onto a Dorian mode or something like that. If you want, like, you know, kind of a modal sort of sound to your data. But we're going to be doing all that. We're going to be looking at, you know, a lot of the data is very noisy. We might be filtering it in ways to kind of smooth out some of the results. Again, nothing very serious. We might look at like the first derivative, look at the slope of the data, things like that. But we're going to be doing that kind of along the way. We're not going to have like a class devoted to like, these are the things we can do to data, you know, and a lot of this is going to be learning by doing, you know. In fact, we're going to start doing right now, I want to start showing you this RTC Mix program. And yeah, you'll get a sense of sort of how the class is going to go, I think. All right. So I'm going to start sharing my screen and my audio again, and hopefully it will work. And again, I'm going to be kind of hiding behind my share screen for a while now. If you've got questions, like, yell them out because I can't see you. Or Nicola, if you can monitor the chat, and if anybody throws something,
I'm good.
You know,
Definitely.
Yeah, just yell at me, okay? Because otherwise I'll barrel on through. This is kind of a weird. I'm glad we're going to be in person again next week because, you know, even though this is a great way to. Am I recording this? Yes. Okay, good. Even though this is a great way to, you know, show off code and things like that, it's hard for me to get a sense of what you all are thinking or feeling. And yeah, it's just kind of weird. Anyhow, so let me go ahead, share my screen, share my sound. Okay, share. All right. Now you see my page again, my home page. Okay, so that worked. Good. All right, and let's get rid of this. Let's get rid of this. Okay, and I'm going to start up Max MSP. Oh, I forgot to show you something really important that Vinay found. Let me bring back here. Okay, if you go to, say, the class webpage, g6602, okay, and you go to this course syllabus, and week 1, there's the assignment. Download these things. If you went to the RTC Mix tilde thing, you went, oh, I want to get that one, and you went there. Now, if you have downloaded this and installed it, and you have one of the new M1 Macintoshes, I had the wrong version up there, and it won't work for you. You'll have to just trash the whole RTC Mix folder that you got and reload this. You got 2.01. And it should be 2.03. We discovered a bug in it last spring that we solved. and somehow the web page got switched back around. Don't know how, but you'll have to do that. And also, you might have to do this thing about Apple being annoying. You know, Vinay, did you have to do that to get it to run?
Yeah, but it let me do it without running the command. I could just click OK. And it
Oh,
said
great.
OK.
Oh, perfect. Okay, good deal. Good deal.
Mhm.
Okay, so sorry about that, guys. Just wanted to make sure you knew that. Yeah, we had to.
Maybe
Yes.
since I was explaining this to one person during the week over email, can you maybe show how RTcmix is placed in the Max library? I think
Good
that's
idea.
maybe good for people that don't know Max.
Good idea. Good idea. Okay, let me click on this and I'm going to download it. Okay, so I'll grab my RTcmix tilde here, get this guy right here. That goes into my downloads folder. Let me bring it out. Okay, and somewhere in here is my RTcmix. There it is. Okay, so I'll bring it out and I'll put it down here on my desktop. Can you all see that? It's down in the corner. Okay. I don't want to replace this. Okay. Keep both. Okay. So let me then open this up. And it'll bring up a Finder window for me, I hope. I don't have my Windows machine up and running right now, so I can't show you that, unfortunately. But it's similar. Okay. All right. So it made a folder here. Let me look at that folder. And in the folder are these two folders, RTcmix and RTcmix help. Okay. What you're going to do is you're going to go over to your main computer and down into users, where you will be, but there's also one called shared. Click on that and you'll see Max 7 or Max 8, or maybe both. If you have both, we'll look at Max 8. And if you go to the library directory, see where it says RTcmix 2.03? All you do, you wouldn't have that there. You would simply take this and drag it over and put it there. Okay? And then that assumes that Max has been closed. If you restart Max, then RTcmix should work for you. Okay? Pretty simple, pretty straightforward, I hope. Okay, just drag, drop, life is good. Okay, Naomi, you raised your hand, I see. That actually worked, and I see some chat stuff going on. Question then.
Yeah. Are you saying we should download it to Macintosh instead of Windows?
No, you can use it on Windows too, okay? That's why I said I can't show you how, just follow the instructions for Windows. I can't show you what to do because I don't have my Windows machine running right now, okay? Tell you what,
It's okay. Are you saying it works better for Macintosh, like
not necessarily.
iMac?
Yeah, the Windows version is pretty good too. I've been doing a lot of Windows work because I've been working in virtual reality, so it's pretty robust and it works pretty well. You know,
Because I have both systems, and should I download both or just one? And if only one, then I prefer download the one that works better.
Okay, I will tell you that I'll be lecturing using my Macintosh because I'm more comfortable with OS X in terms of like presenting stuff. So that might be a better choice for you just for this class. Okay, but you can use it on Windows.
Okay, yeah. Thanks.
All right, let me know if those of you who have Windows machines, if you want to see how to do this, let me know and I'll bring my Windows machine into class next Tuesday and we'll go through installing it that way too, okay? Steve, you have your hand up.
Yeah, actually the same one that Eliana just put up. Okay, I think I'm okay. I think I installed it. But how do I check to see if RtcmX is working?
I will show you that right now, as a matter of fact. Okay. But before I do, any other questions or concerns? Okay. Again, hopefully this should go pretty smoothly. And like I said, get in touch with me or Nicola, and we'll be able to, I'll be a little bit tricky to reach this weekend because I'll be in transit, various places, getting ready to get out there. Yeah. I was going to fly in Saturday night, but I moved my flight to Sunday, which was a smart thing to do. Okay. All right. Here's how you check. Here's what you do. Okay. Let me close off a bunch of this stuff so we have a relatively clean sort of thing. Get rid of this. Get rid of this. Okay. We'll keep that up. We can get rid of this. Okay. All right. And I can get rid of this. I'll do that later. All right. So I'm going to start. Nicole, do you know, should I use Max 7 or Max 8, do you think, for these? I mean,
I think it makes no difference, but maybe since people would have downloaded Max 8 now, that's easier since
okay.
that will be the equivalent graphical surface.
Yeah, the only reason to use Max 7, is anybody using Max 7 in the class? Okay, right. Because I think that 8 patches can run on 7, but I'm not completely sure. Okay. Again, we're not using any advanced features. Actually, we should use Max 8 because we will be using some advanced features when we get into later in the class. Okay, so I'll go ahead and start this up. So you start up Max 8. I don't know if you saw, but I clicked over here on my dock where I've got it. And it'll take it a minute or two because it's got to do a bunch of stuff. Brings up this Max console. This is where you see where errors are. So this is where you can see if RTcmix isn't running or not, okay? And for me, that's all I have. Some will go ahead and bring up some windows for you and stuff like that. I don't have that set. So what I'm going to do is create a new patcher. And that's that, okay? Now, the other thing I'm going to do that you won't need to do is I want to make sure that this is playing its audio into Zoom. Yes. So you can hear what I'm doing. Okay. Shoot. There we go. All right. So this is what you need to do. And this is basically, for most of the stuff that I'm going to do in this class, this is going to be, Max has like, a blue billion different objects. It's a very, very fully featured environment. I'm going to use probably 3 most of the time. The first one I'm going to use, and you can do this by saying, I'm not even sure where the new object thing is. I basically type in, and it brings up a box, okay? Then you type the name of the object in this box. And I'm going to type in RTcmix tilde, and I'm going to give it one parameter, 2, because it's going to be in stereo. With no parameters, it would be in mono, but I'm going to make it stereo. And then you click outside it, and Steve, that's how you check if it's installed. Because if it's installed in this console area, it will tell you version 2.03.
Okay, I'm okay.
Cool. Okay. Let me make this a little bit bigger so that you can see it a little bit better. And the other object I'm going to bring up is I'm going to type in for a new object. I'm going to type in easy DAC tilde. Okay, DAC stands for digital to analog converter. That's converting the digital to analog sound we can hear. Any object in Max that has a tilde means that it deals with audio signals. Okay, that's why RTcmix is there with audio signals and this thing. So this turns into a little speaker icon. And now, this is how you program in Max. These things on the top are called inlets, and you connect stuff to them. These things on the bottom are called outlets, and you connect them to stuff. I'm going to take this outlet, which it says is a signal out, this outlet, which is a signal out, that turns out to be the left and the right stereo channels. I'm going to connect them to the audio out channel 1 and audio out channel 2. So now RTcmix is going to send sound to the output, and we should be able to hear that sound. Okay. Well, I have to have a way of turning the sound on, and for this one, I'm going to type B, and that thing is called a bang in Max parlance. And basically, it's just a thing that you click. All right. Now, if I lock this patch, you can see I can click it. Click, 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 click. But it doesn't do anything. I'm going to unlock it because it needs to be connected to the RTcmix object. Now it will trigger the RTcmix object, okay? Now, a lot of times this locking and unlocking, you're going to see it just kind of happen like that. That's because if you hold the command key or the control key on Windows and you click on this area out here, it'll just automatically lock or unlock it because this is an operation you do like all the time. Okay, next thing I'm going to do is I'm going to save it, okay? Because like I said, I wanted to put these patches up for you all to see. So I'll say save, all right? And I'll go to Data Sonification, Week 2, okay? And it says save as, oh shoot, this stupid, you guys can't see this, but my Zoom console keeps getting in the way there, okay? And I'll call this Basic RTcmix 1, okay? Right, now, if I close the patch, lock the patch, okay, so that I can do stuff, and if I turn the Easy DAC on, and then I click RTcmix, will I get any sound? Well, watch in the console to see what happens when I do that. Oh no, it's in red. That's a bad sign. It says you are triggering a 0-length script. That's because I haven't put anything in the RTcmix object. Like I said, this is the max part. Inside this box is the RTcmix part, and that's where I'm going to be concentrating most of my talk, and most of our action is going to be in there. All right? How do you get in there? Well, when you lock this up, if you double click on it, it brings up an editor window, and you can enter stuff into that window, okay? Now, before I start entering stuff, I'm going to tell you a little bit about RTcmix. It's an object that makes sound. It has a whole bunch of stuff included in it. But the interface, this part right here that we talk about and type into, that's running a particular language that we developed for RTcmix. The guy who did the main work was really into recursion, so he called it MinC. And MinC stands for MinC is not C, because it's kind of like the C programming language, but it really isn't. And remember when I said recursion? Think about it. MinC is not C, M-I-N-C. So MinC is not C. MinC. Yeah. Oh, come on. It's a computer programming joke. What can I say? All right. So it's very much like the C programming language. We wrote this back in 1986, I think, 85. C++ was just a glimmer and Bjarne Strauss size. You know, we've added quite a bit to it. The one thing it does not have, you'll notice, is, and we're going to encounter this in processing. Again, this is more computer sciencey. For those of you who aren't computer scientists, don't worry about this yet. We don't have to do type declarations for variables. Like you don't have to say int x, or you don't have to say float Brad, or anything like that. You can if you want, but it'll basically do kind of on-the-fly self-typing. And the other thing is, if you say x equals 3, you don't have to have a semicolon at the end. Because like I said last time, I wasted years of my life chasing down computer programming bugs because I forgot to type a semicolon at the end of a line. You know, back in the olden days, compilers didn't tell you much good information. So this only has semicolons in certain loop constructs, okay? So it's not C, it's not C. It also does not have things like this for those who are computer scientists, or this, but we're adding them. They're called pre and postfix operators. You still have to kind of write the things out. All right, well, let's have it make some sound. How do we do that, all right? Well, I'm gonna bring up my browsery thing here again, and we're gonna go to rtcmix.org, which is the main page for this, okay? And this is where, now, if you go here and you go to the rtcmix tilde, if you go to this, you notice that it will download the wrong version of that. We've got to get it fixed there too. I think it says down there, yeah. Down at the very bottom here, when I hover on this, it's 2.01. That's wrong for M1 Macintoshes, okay? So don't go there. But do go here for this, the reference, all right? And this is the documentation. There's some tutorials there. I'm going to be putting in a bunch of links for tutorials too in the web page so that you can actually go through and see how this all works. But this is the part where I go the most. Score file commands, those are things that are actually part of that MinC language. There's a big bunch of random number generator things, for example, because they're pretty important for the kind of work we do. Instruments, those are the functions that are actually things that make sound. And that's where I'm going to go first, all right? And they're divided up into synthesis and physical models and filters and delays and things like that. We're going to be concentrating in this class on synthesis and physical models because they make sound. When you give them parameters, they will play something. And that's pretty much what we want to do with data sonification, all right? And the first one we're going to look at is a thing called a physical model. This is separate from the others because this is a fully featured set of a particular kind of way of making sound in the digital world called physical modeling. And it's very fancy. It does some really great sounds. And RTcmix is one of the best places to use these physical models. So we're going to do this thing called Strum2. Now, how do I know? I'm going to show you how you can explore all these later in the class. How do I know to do that? Well, because I wrote the language and I wrote that instrument, okay? This is a thing called the tuned Karplus strong algorithm. It makes it sound very much like a pluck string. And I'm going to click on that. And this is what...
Brad?
Yes.
I'm sorry, there was just one comment about the RTC mix into Max, which, so Sivan, you wrote that it's not loading because it says could not load due to incorrect architecture. Are you using an M1 MacBook? Because
yes, I'm using an M1 Mac.
Okay, because I have an M1 Mac and I get the same problem, and I was trying to figure out what it is, but it seems that several people have the issue.
Okay, first thing, do you have the 2.03? Probably you do. Okay.
Yes, that's what I downloaded, and I get that issue.
Okay, let me quickly show you.
You have to tell Max to open up using Rosetta instead of using the native Mac.
Yeah, but I'm using Max anyways, but it's just that with this object it doesn't open.
Right. No, it's the same thing. I also have the M1, and even if you use the new the new RTC mix, you still need to tell Max to open using Rosetta, like using the Intel version.
Well, yeah, but you do that once when you open Max the first time on your computer, and that's it. You don't need to do that for every individual external.
No, you don't. But to do that, you have to go into applications, right click on Max, do get info, and tell it to launch using Rosetta.
Exactly. But what I'm saying is I'm using Max anyways with Rosetta, but this object doesn't open.
Oh, it's already using Rosetta.
Huh. That's weird. Yeah. Because Vinay did run into this, and he was able to open it with Rosetta.
But you're saying you told, what you had to do is to make sure that this individual object is opened using Rosetta?
No, just Max.
Yeah, but that's not the problem then.
Yeah. Siwan, are you using Rosetta with yours?
Probably not. I don't know how actually.
Okay. I'll show you. Okay. Go over here to applications.
Oh, I saw that. Open using Rosetta.
Yeah.
I'll try it.
Try that. I want to see if yours works, and then if Nicola's doesn't, that's another data point. I have some good news for you guys, though, if this doesn't work. Okay, but see if that'll do it for you. Okay. So shut Max down, of course, and then click it, and then try reopening it. Any success?
I'm still trying.
Okay, sorry. Thanks for doing this, by the way.
Actually, you can keep going. I'll update in the chat.
Okay. Yeah, let me know. Here's the good news. I now own an M1 Mac. Okay. There was an issue between me and Apple's developer program that took a long while to work out, and I was not able to download Xcode. But I have now downloaded it. The M1 Mac is back in New York. When I go back there, I'll be able to compile an RTcmix tilde for the M1 architecture directly, I believe. Okay.
So Vinay, for you, the RTcmix works on your M1?
Yeah.
In Max?
Yeah. Yep, it's working. Okay. There's still some few crashes that are kind of strange and seemingly random, but I can get it to work.
Right. Now, here's the other thing is that you guys might want to look at. Yeah. Here, where is it? You guys didn't have to do any of this nonsense. This is the Apple Gatekeeper thing.
Okay.
So
you mean this quarantine for the objects?
Yeah, where you can basically you can do this nonsense here inside a terminal window. You drag the whole RTcmix folder into that line in the terminal, so that it looks like this, even though it will now say 2.03. Apple does weird things, but it sounds like this is a different issue, because it would have told you that it was damaged or something like that. Okay. Yeah. Okay. Well, shall I keep on going then? Yeah. Siwan, let us know what happens. Okay. And we'll take a look at this and try and get it to work. You know, worst comes to worst, we can do some stuff with PD. But
that's interesting. So it seems that for Sivan it's not working. I actually did what you said, Vinay, and now for me it works, which is a big surprise to me, I have to say, that it was working before, but once I hit this thing in info to say open with Rosetta, then it recognized the object. So it seems that you really have to do it so that it sort of applies this to everything. It's quite surprising because I mean, I got this computer a few weeks before and I've also been performing using Max, no problem.
Yeah,
ever to recognize objects, but now it seems to really change the way that it's sort of researching the objects or opening the objects.
Yeah, here's what I suspect is happening.
Okay, it's solved.
Okay.
Sivan says.
Yeah. Oh, great. Here's what I think is happening with this. Okay, and like I said, I'll go ahead and create an M1 version of RTcmix so we don't have to deal with it anymore. I believe probably inside MaxMSP. MaxMSP is running with Rosetta, but its loader, when it's loading in, dynamically loading in these objects, it's not necessarily going to be looking for a Rosetta architecture. You have to explicitly tell it that all objects now on its path are Rosetta objects. You know, so when you brought in RTcmix, it was a new object. It defaulted to thinking, well, that's an M1 architecture object, and that's why you got the error message. Okay, so good. All right, sorry, gang. See, this is life at the bleeding edge. We're just really carving out the cutting edge of whatever here. Okay, all right. Let's go back to this. All right. So I brought up this Strum2 pluck string physical model. And this is how you kind of read this documentation. This is basically what it's going to look like inside our RTcmix window, okay? And then this tells you what each one of those things do. Now, they're called P fields in RTcmix parlance. That stands for positional field. And that means back then, parameters were different. You know, you could put them in as assignments, or you could put them in particular positions. We use positional location here. So the very first one, which starting in C, we number from 0, that's the output start time in seconds. Let me make this a little bit bigger, okay? All right. The second, P1, is the duration. The third, P2, is the amplitude. Fourth is the pitch, and all that. You know, that's how, and then down here it explains what some of these parameters are, and it gives you some example scores that you can run. Well, here's what I'm going to do. I'm going to take this whole thing and I'm going to copy it out, okay? And now I'm going to go back to MaxMSP, open up my window, and I'm going to paste that in. Where's my paste? Right there. All right. And I'm going to comment it out. Now, by putting in those 2 backslashes, that means that the RTcmix parser will not see it. It's just a comment. Okay, and then I'm going to paste it in again, and I'm going to put in these parameters. The reason I put that up there was to remind me what they are once I start putting numbers in. Well, outskip. You know, I can go back there and go output start time in seconds. Now, this is what's fun. RTcmix, as I said, maybe I forgot to say it. It's a scheduled language. That means that we can actually schedule events at any time in the future, which is very powerful for people doing musical stuff. You want to have a handle on time, all right? So basically, this is the number of seconds that have elapsed from when you hit that bang button to trigger the script. So we want to make sound right away, so I'll say 0. Duration, let's just make it be 3.5 seconds, because I happen to know that's going to be a good number. Also notice that I'm freely mixing integers and floating points. That's a feature of this language. Now the amplitude. That's a little bit weird because normally people will say 0 is no amp, 1 is full amplitude. This reflects the world back in the mid-1980s. The amplitude, and we keep arguing about whether or not we're going to change this. It'll break all of our existing scripts probably. This is based on a 16-bit quantity. So the range is 0 to 32,768. That's full amplitude, okay? And that number is 2 to the 16th, or 2 to the 15th minus 1, I forgot, okay? So let's just put in 20,000, because that's about, you know, 2/3 of the way through. That's going to be a pretty good number, okay? Now the pitch. We're going to be talking about different ways. RTcmix has a lot of ways of specifying pitch. I'll do what I did last time. Let's just specify it in absolute hertz. So I'll just say 443.78 hertz. That's one of the fun things, is we can get very precise about, you know, the frequency that we want. Now this thing that says squish, that's one of the things that you would have to read the documentation for. This is a feature of this physical model, and it is how hard is the physically modeled plectrum that you're using to activate the string that makes the sound here. 10 is very fleshy. It's like you're playing it with a really fat thumb and it's going fa, 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 fa. 0 is like you're playing with a very strong metallic plucker, okay? So 0 to 10 is the range. I'll just say 1. Decay time, that's nothing we need to really worry about. Our duration is 3.5. So let's make the decay time be 3.5. And then you'll notice that there's an open bracket here, okay? That's because that's an optional parameter, okay? But let's go ahead and put this in, 3.5. Pan, stereo, left and right. 0 goes in the left channel, 1 goes in the right channel. 0.5 goes in the middle, okay? And again, it's optional. It defaults to 0. So if you have a stereo thing and I left that as 0, or I didn't specify, it would all go in the left channel. But I want it to come out both. So now we've filled in this instrument, I call it. It's really a function. With all these parameters, it can make sound. So let's close this off. By the way, you have to close off that window for it to be reflected in your RTcmix. If you type in the window and then go out here and click it, it won't reflect any of the changes you've made until you've closed the window. But now I'm going to save it in case I mistyped and it crashed. Now I turn it on and I hit the bang and I hear a plucked string sound. Okay. Now, I don't know if you noticed, this is one of the features that's cool about physical models, but all of the timbres of those plucks were slightly different. That's a feature of it being a physical model, which makes it kind of real, which is sort of fun. Okay? So, let me see. Yeah, okay. All right, I'm going to back up and go through some stuff that I forgot to show you. You know, and then we're going to come back to this and we're going to start filling it out in terms of being a programming language. All right. Actually, you know what? Let me not do that. What I'm going to do is put some links in the web page. Basically, I wanted to show you where you could go to get more information and tutorials and things like that. But they're just links. There's a good friend of mine runs the computer music studios. He's on the faculty of Indiana University at the School of Music there. And he's got a whole bunch of good tutorials that walk you through a lot of the RTcmix stuff. A guy up at, which it's one of those upstate New York colleges, smaller colleges. I forgot which one. It's not Skidmore. Something else. Has written a whole book, and you can actually, you know, look up stuff in there. One of the things that we are going to be dealing with is how do you get data into this object? Because obviously that's kind of what we're here to do. But in the meantime, let's go continue programming for fun, all right? And one of the things to realize is that all of these numbers can be replaced by variables, okay? For example, I can replace this variable. I can make a variable called frequency. And we'll say frequency equals, and you saw this last time too, IRAND from 200 to 700, okay? IRAND, what the heck is IRAND? Well, let's go back out here to my window. Go back up to the reference. And if you go to the score file, which this is, down here under random number commands, there's all these cool random number generators. IRAND returns a random number within a specified range. You can give it a minimum and a maximum. So what I've done is with my RTcmix scripty thing here, is I've said, give me a random number every time you get triggered between 200 and 700. Then I can replace this frequency value with freak there. Okay? So let me close off that window. And now we'll hear. So every time I triggered the script, it generated a different random number. Okay? Right. Now, what we're going to be interested in is every time we trigger the script, it's going to generate a different pitch based on some external source of information. And we'll be getting to that probably next time. Okay, we're going to be looking at some fun chaotic attractor equations. All right. Well, this is all well and good, but you know, I'm a really lazy guy, and I hate clicking that button. Okay. Now, there's two ways that I can automatically click that button. One way is to use a max MSP object called metro, which stands for metronome, which will generate at a given rate clicks for that button. But you know what? I don't want to do that because I want all of my information processing to be done within this RTcmix language. Why? Because then I can import it into Unity or open frameworks or something like that. I can't import all the maxi stuff into those things. I have to do a different sort of thing. So I'm going to go in here. I'm going to take advantage of the fact that this is, like I said, a programming language. Okay? And let me just create a little loop here. Okay? For I equals 0, I is less than 10, I equals I plus 1. By the way, I could do this. We do have these operators for those who are into computer sciencey stuff. Okay? But basically, what I've done is I've created a weird loopy thing here. It's going to start out with this variable I set to 0. And as long as it's still less than 10, it's going to execute anything within those curly brackets. All right? And then it's going to add 1 to that I thing. So I is going to go 0, 1, 2, 3, 4, until finally it's no longer less than 10. Then it stops the loop. Okay? By the way, here's a fun trivia thing to try and keep people who know this stuff already interested. Do you know why you use that variable I or that variable n so much for counting in programming? I mean, you use it in C++, you use it in Java, you use it in JavaScript. Do you know why? Anybody? I do, because I'm old. Because in the programming language Fortran, any variable that started with I, J, K, L, M, or N was an integer. All other variables were floating points. So the easiest integer to just grab as a variable was I. True fact. Anyhow, let's take this, okay, and let's put this stuff that I just typed inside our loop, okay? Now, what would happen if I ran this loop like this? Well, we can find out because we can turn it off. And you know what we're hoping will happen will be it's going to like do that kind of do like I was doing it, like I was you know, clicking all the things. But that's not what you're going to hear. What you're going to hear is this. Which sounds kind of weirdly sinister, but that's not what we wanted to have happen. Why is that? Well, look, the start time is always 0 in those cases, okay? What I want to do is I want to declare another variable out here, initially set it to 0, put that variable in here, and then after it makes a note, I'm going to say start equals start plus 0.4. Now when I run this, and basically I'm going to save this now as something else. I forgot to do that. Save as basic RTcmix. I'll move this down here again. We'll call this 2. Okay. Now I will hear. Okay. So now what it's doing is every time it generates a note, it takes that start time of 0 and it adds 0.4 to it. So that means I'm going to get notes at 0, at time 0.4, at time 0.8, at time 1.2. That's that scheduled aspect of this language, okay? And I can make it much faster if I wanted, okay? And you can even do fun things like this. You can say start plus irand 0.1, 0.5, comma, 0.5. Okay. Okay, let me say this is something else. Okay, and now we can hear. Okay. So that's starting to sound kind of fun. You know, we can do all sorts of fun things with that. Let's do one more thing, and then what am I going to do next? Yeah, then I'm going to do one more final thing. I'm getting tired of this being in mono, okay? Now remember I said that this was 0 to 1. Let's go back out here to our RTcmix documentation, and here's a random, whoa, look, it returns a random number between, there's a kind of a weird thing, minus 0.0 and 1.0. So there's a function called random, value equals random, and it just returns a random number between 0 and 1. Well, let's go back out to our fun little RTcmix script here and place this with random. Now what are we going to hear? Okay, this. Are you guys hearing that in stereo? I hope so. So you should be able to hear it kind of like, okay. All right, cool. Now, kind of cool, it's only generating 10 notes. Suppose I wanted to just kind of generate notes for a long time. Suppose I really love the way this is sounding, and I just want it to be ambient music for me, like for the rest of the day. I mean, one thing I could do is like do that, but that's kind of dumb, okay? Because first of all, I can't interact with it, and we're going to be talking about that in a second too. And secondly, it's going to place a little bit of a memory load in the computer. It won't be too bad because we're pretty good about this language. But here's what I can do, okay? Remember I said that as long as I is less than 10, it's going to do this loop. And once it does this loop, you know, it's executing everything in here sequentially. It falls out of the loop, and I can do one more thing. I can say max bang. Okay, and I'm leaving something out of this, all right? And I can then take that, and this third thing, this is where stuff comes out of RTcmix that isn't a signal. And what's going to come out of this is a bang signal. And I can actually take this, move it around there, and have it bang that bang. All right? Now, here's what I've left out. Max bang, I'm not going to go to the documentation, takes a parameter, which is what is the time, again, it's scheduled language, what is the time to generate a bang? Well, we've been adding to the variable start. So the next thing that we should hear is at that particular time start. So we're going to tell it to generate a max bang at that point, and it will come back and redo this whole script again. So now, okay, let me save this as something else. Okay. Max patch. So now we should see this happen. Watch the bang up here in particular. And here's what's fun. Here's what's fun. You can actually hit the bang and generate a second set of things happening too. Or I can generate a third thing. So you could get carried away and really do some computer music with this stuff, okay? All right. Right, so now I hope you're getting a sense that this is kind of a powerful thing, all right? Now, yeah. All right. Now, one of the things that I need to show now is we've got this great sort of programming environment happening here. And again, we're going to be filling that out even more as we go through the class. You know, as we start bringing in other constructs, there's lots of flow control. You can do if statements, you can do while statements, all kinds of things like that. But one of the biggest things we need to be able to do is to get data inside this thing, you know, because we're going to be having data sets generating stuff, equations generating stuff. How do we do that? Well, there's several mechanisms for getting data into and executing RTcmix script, all right? And I'm going to do one thing here. I'm going to declare two variables up here. One is going to be the low frequency. I'm going to call that $1. Then I'm going to have a high frequency. I'm going to call that $2. All right? These variables, these dollar variables, are special. That means that they're going to get their values as they're being set somewhere outside the RTcmix object. All right? What I'm going to do is I'm going to then modify this IRAND so that it's going to have a low frequency there, and then a, ooh, wrong one, yikes, up here, low frequency and high frequency. Okay, so what this is going to allow me to do is to dynamically change the range of random numbers that's going to be generated by this script. Okay, how do I then set these outside? Well, here's what I do. Okay, let me close this off. And I'll save this as something else. Save as. Okay, we'll call this now outside var 1. Okay, the one how to spell too. Actually, let me back off a little bit. Anybody have any questions or anything? Is this all being kind of clear? I hope it's not too difficult for those who haven't encountered programming. I hope it's not too boring for those who have. Everything okay so far?
I'm gonna have to rewatch it,
Okay.
but it is very unfamiliar, and I'm kind of intimidated.
Okay, remember, Nicola and I are both here to help too, okay? Definitely, you know, take a look and see and try this stuff out. Like I said, I'm going to be putting all of these things online, and you'll be able to download them, load them into Max. I'll show you how to do that before we end class tonight, and just start them out and see what you can do, okay? All right, now, in fact, what are we going to do here? Yeah, I only have a couple more things I'm going to show you tonight, okay? Which is good because we only have about half an hour left. All right, but this first thing, how do I get these values to come in, all right? Well, I need to have a way in Maximus P of generating a value, and the easiest way is to use a thing called a number box, okay? And I can just type in a number here, 100, or I can actually click on it and move things up and down, okay, like that, to change the numbers. I'm clicking on that little arrowy thing, okay? All right, so I can set a low frequency value and a high frequency value by having two of those number boxes, okay? Let me have a second one here. Okay, I'll put that one over here, okay? And just so that I can remember what this is, I'll call this low freak, and I'll call this high freak. Move that there, move that there, okay? All right, how do I get those values to come in to here, all right? Well, I do it by creating a max message, okay? And that's done with a message box, type M. It's also one of these things up here. And what I'm going to do is I'm going to say here, this message is going to say var 1, $1. And this one is also going to say, this one, oops, wrong one, var 2, $1. Oops. What do these guys do? Well, again, I'll put up some links to some MaxMSP tutorials. We can generally see what anything in MaxMSP is doing by putting in a print object. And if I connect that to that, we can see what comes out in this console. Watch what happens when I type a number here, okay, say 200, bang. Notice that it says var1 200. Okay. Now, let me make this guy go to a print too. If I type, say, 500 there, you'll say var2 500. And if I scroll this up and down, see it's saying var1, that one's saying var2, okay? That corresponds to this $1 and $2. So all I have to do is, instead of sending it to print, send it into RTcmix, like that. Okay. So now, when I move this up, this says, oh, that's var1. The $1 means it's the very first one coming in, by the way. Just kind of like the same way that $1 is the same thing here in RTcmix, okay? So when I scroll this up and down, it goes, oh, $1 is set to that. When I scroll this one up and down, it goes, oh, var2 is set to that. So $1 will be that number. $2 will be that number, okay? So now, let's go ahead and start this up. I'm going to make it go a little bit faster. I'm going to generate only 2 notes each time. And let's make this be IRAN between 0.05 and 0.15. Okay? So that means that it's going to be generating notes every 500ths to 1500ths of a second, or 0.05 of a second to 0.15 of a second. So these are going to be pretty fast notes, okay? And now, turn this up. Let me set my low frequency to something, set my high frequency to something, and I get this. And now, okay, could you hear how that was working? Okay, I was basically,
very well.
yeah, changing the range on that random number generator. Also notice that at one point I made a mistake, and I made this one actually go higher than the high freq. That's okay. It'll still generate a value between those 2 numbers, only it'll do it like weirdly inverted. Okay, Naomi, you've got your hand up and I can see it. What's up?
The question, VAR, is that a command for volume?
No, it stands for variable. Okay,
Variable.
That's actually, yes, anything out here outside the RTcmix thing, this is all part of MaxMSP. And we're using MaxMSP is going to be kind of like our glue to get things from data sets into RTcmix, or we're going to use it to get from data sets into our processing language and things like that. Okay, so this is just saying I have a variable. It's going to be variable 1. I have a variable here. It's going to be variable 2. That corresponds to $1 and $2 inside there. And this is saying variable 1 is going to be set to this. This is a little confusing here. This $1 value, that just means the first one coming in there. Same thing here, first one coming in there. So $1 inside RTcmix is going to be set to that one. $2 inside RTcmix is going to be set to that one. Okay.
I see. And the reason we hear like 2 string of music that playing at the same time is because you preconditioned RTcmix to 2.
I'm not sure what you're hearing. It may
you know, what you just play, I can see there are like a 2 string of thread like going in.
Oh, right. What that's doing is that's changing. I'm choosing a random frequency value between that number and that number. And that number is set here and here. So I'm choosing to play, like if I played this at 440 hertz, I played this at 440.1 hertz, okay, you're going to hear pretty much the same note, 440.1, okay? You're going to hear pretty much the same note in each one of these, okay? Oops. I didn't do it right. Oh, that's because it's an integer, okay.
Yeah, I got you. Does
right,
that mean if you put a high freq to 400, then it should be one sound because two that merge together.
Exactly. So these are... Okay, if I make this exactly... There you go. See how that's working? And now I can raise this up. Okay, you see how that works then?
Yeah.
Okay, right, and that was because... Yeah, go ahead.
The reason you put $1 and $2 is because this program is designated using $sign.
Yes, basically dollar signs means it's coming from outside that particular object. So this $1 says the number is coming from outside here. It's coming as the first one in, so it's var1, okay? This $1 is the first one coming in, so number 2 is set to this. This says $1 is coming from outside somewhere, $2 is coming from outside somewhere. $1 is going to come from that guy. $2, var2 is going to come from that guy.
One thing that might be interesting to also say, just for people that don't know Max yet, is that these number boxes, you can make them do different things if you open the inspector, which is where you can also change them to be able to do floating point or MIDI notes or whatever exactly.
Right.
So it's here on the top, it's display format. There you can change how this number box is working, and that's very important to know if you work with it, because so the standard assumption in your Max, I don't know if that can actually be changed, is always that it comes as a decimal formation. And so every time you create a number object and you want it to be doing something else than only natural numbers, then you need to go into the inspector and really change that.
Right. And we're going to be hitting that again in the future too. Okay. So what I did to get this was basically I unlocked the patch down here by command clicking on it. If I select this, then you can actually go up to object and you can say inspector there, or what I did was type command I. Max has a lot of key accelerators. Okay. And that brings up all these things. You can change the color of it. You can change how it looks. You can change the font, you know, and you can change whether or not it's going to use a decimal point or not, you know, or Roland octal. I didn't even know about that. Nicola, good grief, that's pretty bizarre. Yeah, that's the other one that people are going to use a lot of. I have no idea what Roland octal is. It's weird. So command I will shut that guy back up. Okay. All right. Okay. All right. Now, that's all well and good if you really like those plucky sounds, right? But suppose you want something a bit more continuous, all right? Well, you're going to use a different instrument for that, all right? And I'm going to start a whole new patcher thing here, I think. Oh, sorry. This is what's bothering me. This cat came over and started rubbing its head on my computer. So, go away. For some reason, my cat hates Zoom. Now, at some point in probably the not too distant future, you're going to hear me scream, ah! That's because it's going to attack my legs because it hates when I'm on Zoom. All right. So if that happens, just be forewarned. All right. So let me close this off. I'm going to keep all this for now. Okay. And like I said, I want to make sure to show you how to open up these patches at the end. Okay. So let me close this guy off. Okay. I will save it. Okay, let me start up a new one. Okay, new patcher. All right, let me do my typical thing where I'm going to put in an RTC mix with 2 channels. Okay, make it a little bit bigger. That's a little bit too big maybe. Okay, let me put in my EZ DAC. Connect my outputs. Let me put in the bang so I can trigger it. Okay, and I'm going to hold off on doing the circulating bang for a little bit, okay? And I'm going to call this, let me save it as something. Let me save. Okay, I'm going to call this wavetable1.maxpatch. Okay, why did I call it that? Well, I'm going to lock my patch is locked up. I'm going to open up my programming window, go back out here, and let's go out to our instruments. And let's go down here. Ooh, wavetable oscillator. Okay, now there's a bunch of instruments, and like I said, in addition to showing you how to open up a MaxPatch, I want to show you how you can explore these before we close up shop today. I'm going to be showing you different instruments as the course of this goes. So, for example, I'm not going to show you everything about this makes this sound, this makes this sound, this makes this sound. I'm going to use them in the course of looking at how we're going to be sonifying data so that you can kind of get a sense of what these instruments are about. But I'm going to use wavetable because that's kind of different than what the pluck string is, okay? What wavetable does is it plays what we in the biz call a wavetable. Well, what's a wavetable? A wavetable is a part in computer memory where we have stored one cycle of an audio waveform. I mean, typically this would be one cycle of a sine wave, and that's exactly what we're going to use right now. So in order to make sound with that, you can say to the computer, that's my sine wave. I want you to play it back with a frequency of 500 hertz or a frequency of 700 hertz, you know, things like that. That reminds me, I forgot to kind of ask this first of all, but how many of you are really radically unfamiliar with pitches and frequencies? Is this something I should take a quick digression into? Just shout it out. What do you think? Okay, are you pretty, basically hearing, we hear from about 20 vibrations per second up to about 20,000 vibrations per second if you're newborn and your hearing is really good. I just had my hearing checked and I start falling off in my right ear about 9,000 hertz now. My left ear is still pretty good. It goes up to about 15K, 14K, which is pretty remarkable given that I played in a lot of annoying punk bands when I was younger. Yeah, and the general thing is middle C is 261.5 hertz, I think. So about 250 hertz is middle C. Now remember, this is a logarithmic scale, so the C above middle C is 500 hertz. The C above that is 1,000 hertz. The C above that is 2,000 hertz. Ah! I told you that would happen. Did I tell you that would happen? That cat just attacked me. Bad kitty. Bad kitty. God, that's annoying. Why does it hate Zoom? I don't know. I don't know if you see, it's like grabbing my arm. I'm glad I warned you guys. Okay. All right. Well, anyhow, you get the idea. So basically, when we use frequency scales, we just use this. Now, I'm going to show you how we can actually specify pitch directly, though. So you don't have to like deal with like translating to middle C. Oh, I want to play a middle C, you know, something like that. But let's go ahead and deal with this wavetable. Okay, so it's going to play a waveform, and that means not like the pluck string. It's going to be a continuous sound because it's going to continuously play that waveform. So let's go back to Max MSP, and again, I'm going to put in a comment here, and then let's first of all get some sound out of it. Okay, let's start at time 0. Again, let's make it be 3.5. Just because I like that number. Amplitude, we'll make it be 20,000 again. Pitch, let's say 300 hertz, okay? Pan, we'll make it be 0.5 right in the middle. And now this thing called the wavetable, that's an optional parameter. I'm not going to use it. I'm going to use the default, which is a sine wave, okay? So let's make sure that we're getting some sound out of this. I've saved it as wavetable 1. Now if I click the bang, I should hear a nice 300 hertz sine tone, okay? Now, we can do all the stuff we did with strum. We can put it inside a loop, we can schedule it, we can make the notes small and things like that. Let me just show you for fun, what if I actually set this to be, say, 7? Okay, I meant to show this to you earlier, but this is the scheduling aspect of the thing. Look what happens. I'm going to click the bang. 1, 2, 3, 4, 5, 6, 7. Okay, so that just demonstrates that you can schedule this stuff, okay? Now, this is cool. I'm going to make it be longer, okay? Because like I said, I wanted a long droney sound out of this, okay? Listen to the end. Yeah. Oh, there's a glitch ahead of time. I'm going to play it one more time, okay? Listen to the end now. Do you hear there's a big clunk, a big click at the end? Well, you didn't hear it, but there's also a big click at the beginning, you know, when I turned it on, because you're just arbitrarily starting this note, and it might be, actually, you might end it, and the sine wave might be partway through its cycle, and it's just going to like dramatically cut off, and you'll get a big click out of that. How can we set this so that we can like have the note nicely fade in and the note nicely fade out? Well, we have to construct a thing called an envelope, an amplitude envelope. And the thing to do that, I'm not going to show you the documentation page for it. I'm just going to do it here. I'm going to say amp env equals, and we use a command called make table. All right, this is going to be the weirdest, the most esoteric thing I'm going to show you tonight, okay? And we're going to call it quits after this, after I show you how you load your patches and stuff like that, okay? Now, make table is going to create like another part of computer memory that's going to store something that we're going to then access for the note, okay? And this make table, I'm going to make a line. Then you have to type in this parameter 1000. That's basically computer storage. We're trying to get rid of that one too. Just know you have to type it in. And then because we're making a line, make table allows you to make all kinds of different shapes in the computer. These next parameters are dictated by this line. What it is, it's time and then amplitude point. So at time 0 in the note, the amplitude is going to be 0.0. At time, say, it's a 7-second long note. Let's say at time 2.0 seconds, it's going to be at an amplitude of 1. Then at time maybe 5 seconds, it'll be at an amplitude of 1. And then at time 7 seconds, it'll be at an amplitude of 0. Tighten this up a little bit. Now again, I did this on purpose. I freely mixed decimal numbers with integer numbers just to show you you can do that in RTcmix, okay? So now I've got this nice sort of shape. It goes at time 0, it'll be 0. Then it fades up to time 2, it'll be 1. Stays at 1 to time 5, and then fades back down to 0 at time 7. Note is 7 seconds long. All we have to do is take that amplitude and multiply it by that amp env. Because remember, this is going from 0 up to 1 to 0. That means that this will go from 0 up to 20,000 and then back to 0 again. So now, if I play this, let me save this as, okay, we'll call this wavetable 2. Now it'll fade up and fade down. Okay? Yeah. Now here's the fun thing. Suppose I say, well, that note's really too long, you know. I really want it to be only 3 seconds long. Do I have to go back in and type in all these time points? Because that was based on it being 7 seconds long. No, you don't have to do that. Because what will happen is that RTcmix will automatically scale that expanse of time to the duration of the note. So this 7 will become a 3. This 5 will probably become something like 2.1. This 2 will become something like 1, you know. So basically, it will still do the fade up and fade down. It'll just do it faster and fit within the 3 seconds. And to show you, here we go. Okay. And you can go the opposite direction too, of course. You can make that be longer than 7 seconds. So in essence, this time scale that you use here can be arbitrary. I typically use 0 to 100 as my kind of scale, and then I just scale it to whatever the value of the note is. In fact, I can make this be 0.1, and it'll be very quick fade up and fade down, okay? All right, we'll leave this like this, okay? So that's kind of what what wavetable does. Now, do one more thing. I left out that optional parameter that was the wavetable. I can actually use makeTable to create a waveform other than a sine wave, okay? So I can say wavetable equals, I'll just say wave equals makeTable, and then I can say wave, and I can say saw for a sawtooth waveform, all right? And then down here, I can type wave, and now I will hear this. Yeah, those glitches, again, that's from Zoom. Sorry about that. So when you hear that click, you know, that's basically the internet being happy about things, okay? But basically, and I won't go into the details, but you can create all kinds of different waveforms with this. So this is very good for getting different timbres and different sort of effects out of your wavetable. All right, now the thing I'm not going to do, because we're running out of time, is when I showed you where's my open recent patcher? Okay. When I showed you this, okay, and we had these outside variables coming in, okay, they were coming in at what we call schedule time. So basically it would set these values, and then it would do all that and set all those values and get all the notes happening between now and whenever we've decided that we're going to go, okay? So essentially, if I set this to be something like 200, okay, and I set this up to be, say, 100 and then 101, I should make it higher than that. Let's make it be 300 and then 301. Okay, and let me start it out. Can I change this? Notice that it wasn't changing. Okay, that's because it scheduled all 200 notes when I hit the bang, and it scheduled them with the values that it had when I hit that bang. Okay, and those notes are just playing now, you know, and I'm saying, no, do new values, but remember, it's not going to do this whole script again until that max bang triggers 200 notes from now, okay? So that's what we call setting the values at schedule time. What I'm going to show you next week is that you can actually set this value dynamically so that it can happen actually as the node is executing. And that's using a slightly different mechanism, and we're not going to go into it now. But just be forewarned that that's going to be coming your way soon, okay? All right, so we're going to call it quits for now. Again, there's a bit more that I wanted to go through. This class is going to be pretty free form in terms of hewing to the syllabus, but I also want to get into the processing stuff. Actually, I'm not sure if I'm doing processing next week or the following week. Because next time I definitely want to show you how you then get an actual equation controlling this stuff, okay? But let me show you something, okay? What's going to happen is you're going to get, I'm going to put on the line basically a, oh, that reminds me, I wanted to tell you all something. You're going to get a bunch of these things in a folder, in an archive compressed folder you can download, and if you double click on it, it'll turn into a folder like this. And basically all you need to do is double click on this, and it brings up the stuff that we did in class. And then you can run it and go, oh my, it did that. Why did it do that? And then you can go in and kind of change around some of the numbers. So hopefully all these will give you some kind of a little toolkit to play with. You know, you can look at what we just did, that wavetable. I mean, I can double click on that. Well, this is wrong. Huh. For some reason, it's not letting me, my computer's doing weird things, guys. Hold on a minute. Oh, I think I know what happened. No? Huh. Oh, there we go. Yeah, for some reason I couldn't click on that. That's weird. But if I double click on that, that'll bring up this thing. And I can look in and say, oh, that's what we did. We turned it into a sawtooth wave, you know. What if I type in square or something like that, you know, or I look at the documentation to figure stuff out. So hopefully this will give you something to go on and you can start kind of like doing these things, all right? The final thing that I wanted to show you is how you can check out a lot of these different instruments and things like that. And let me go back to Maximus P. Do I have an open patcher up here? No, I don't. Let me bring up my basic one again, okay? Now, bring this up a little bit. Now, if I unlock the patch and I option click on the RTC Mix tilde thing, it brings up this huge thing, which is the help patcher for RTC Mix tilde, all right? And you can say, oh, here's a very basic RTC Mix patch. Look, I can turn it on and play it. Or, oh, here's one. It says it's a basic RT scripting example. I can click on that, turn it on, and play it. Okay, and I can double click on it and see the script. Oh, that's kind of cute. And there's all kinds of things. This is one of my favorites. This is basically using a wavetable to generate some nice long drony sounds. Okay, hold on. So this will kind of go on forever, you know, if you're really into it, you know, turn it down, put it in the background. Oh, bliss, new agey bliss. Okay, so there's all kinds of fun stuff like that. But the main thing I want to show you is over here, these two, Score File Sampler. Score File Sampler 2 is a little tricky because that uses a feature that I haven't told you about at all, which isn't going to actually be that important for this class. But Score File Sampler 1, if I click on that, brings up this thing. And then load in an example from the sample scores. If I click on this little arrow, here's a whole bunch of sample scores. And I go, oh my God, that looks, what? There's this one called Claire1.score. What do you suppose it sounds like? Well, if I click on it, it loads it in. I can turn this on and hit play. It sounds like a really badly played tinny clarinet. That's what the score looks like. So it's one of those physical models. It's kind of cool. Or what if I wanted to hear, ooh, what do you suppose, what the heck does a Latocarfian sound like? Well, let's play it and find out. I'm going to turn this down because I know what it sounds like. It's a way of generating a particular kind of noise. Okay, so that may be not so helpful for us as we go about sonifying stuff. Multi-wave 3. Ooh, it's a multi-wave. It's got to be good. It's got multi-waves. Oh, yeah. Okay, so that's pretty cool. So you can actually go through and try a bunch of these things out. Now, be forewarned, some of these things, notice that in addition to the speaker, I have a little microphone thing up here. Some of these will actually do live input, like this. Whoa, I'm in the middle of an echo chamber. Okay, so you can see how to do that kind of stuff, all right? Like I said, easy to do. Bring this up, unlock the patch, option click, and it shows you all this stuff, and you can try things out. Now, you know, they may crash now and then, but hey, what's life for? Okay, let me stop my sharing.
Maybe also good to mention that every Max object has a help file attached, usually, yes. Unless there is some like custom ones that come without. But usually every Max file has a help file that comes attached and also a reference. Which specifically tells you, for example, integers to write into the object and things like this.
Yeah.
And that's something that I think is a very helpful feature about Max MSP, because it makes it quite easy to sort of get to know these objects and learn about them as you go, because the software already gives you that information if you use the help file or the reference options, which is definitely a very quick way to learn things. So also, for example, if you don't know how does a bang work, how does a toggle work, how does a number object work, all of these come with help files, which you can click in if you don't know how they work.
Yeah, Max is actually very well documented. It's one of the best documented environments that I've seen, and yeah, like I said, on the class webpage, it'll take me like a few days, probably this weekend sometime. I'll get the stuff up on the webpage, and you'll be able to click and download. And the recording of the class is going to be up there now too, so you can go back and take a look at all this wonderful stuff that we did tonight. Okay. All right. Well, that's it. Naomi, you got your hand up. What's up?
Okay, question. Thank you for showing us. It's very interesting that we can turn the like a non-live music into music. However, I mean, after learning this, master this program, what is the application of this in real life?
Okay, that's we're going to get into that next week, because we're actually going to take a look at a chaotic equation, and we're going to turn it into sound. And there's some features of it that I think are kind of interesting in terms of how we apprehend the stuff as sound. So one way is to look at it as a research tool in that sense, But another way is, and probably the way that I do it, is it's just fun to do. This is a way you can make new pieces of music. This is a way you can create things that have not been heard before. And that's that's why I'm in the music department and I'm not in the computer science department, because I don't actually have to know what I'm doing.
Sorry to interrupt you.
Oh, no problem.
Is this program allow us to maybe editing the existing music?
You can. We are going to look at some examples of that later in the class, where we will take an existing sound and we will do an analysis of it, and then use the analysis inside this context, and we can change the way that it then gets played, the way that it sounds. We can edit it, if there's any number of things. Now, it's not your typical editing thing that you're used to with, say, a program like Logic, or a program like Audacity. Yeah, something like that, where you clip sounds and you kind of put them in different places. This is a much different kind of editing. This is changing the structure of the sound itself to create some kind of new sound. So yeah, it's a little esoteric, but hey, this is how you invent the future, as futurists like to say, And yeah, we've had a pretty good track record here at the Computer Music Center. A lot of things that we're doing, 10, 20 years ago are now being done like lots of places. Like we invented one of the first sound editors here, graphical editors, on the Sun workstation. So yeah, I don't know if that answers your question or not, but yeah. That's the other thing is, like I said, it's really hard to get a bad grade in this class, because in one sense, it doesn't really matter what you do, as long as you just do something, because, you'll never know what you come up with until you try doing something. And it may be something that really takes a hold of you and you devote the rest of your life to it, or maybe not. Yeah. I don't know if that's a good answer, but that's the best one I can come up with. Yeah. Sivan, what do you say?
Yeah, hi. I just got a logistic question, that if we want to discuss anything, or just chatting with each other in the class, do we have a platform, for example, add or
yeah, like Discord or something like that,
Yeah,
or
yeah, yeah.
Slack. We don't. Nicola how adept are you at setting that kind of stuff up?
Yeah, I can set up a Slack channel. That's no problem. Or Discord. I don't know what. Can we do Discord? Yeah, well then let's do Discord. Yeah, sure. I
Do
can
you want
set
to
that
do you
up.
want to do that? See, I'm old and I'm not very good at that stuff. I don't really even know how to use Discord or Slack.
Yeah, I can set it up. Sure.
Okay. Yeah, if you need help, I mean, Seth's pretty good at this too. But yeah, if you want to do it, yeah, that's probably a good idea because you can help you learn from each other. And again, next week we're all going to be meeting in person too, so we can kind of like hang out a little bit then too, right? Hey, listen, I have no problem if the class is going off the rails or it's going too slow or too fast or something like this. I have no problem completely changing the syllabus. I mean, we've got some special guest speakers coming in, but they can come in, and do their talk at any point. So, yeah, don't worry too much. Okay, that's a good idea though. All right, Nicola, you've got an assignment. Okay, all right. Stay tuned for next time. We'll roll it out. Okay. Yeah. Anybody else? Okay. I did forget to make an announcement of something. Okay. Let me. Yeah, you know what? I'm going to share my screen again real quick just to show you this. Okay. I don't need to share my sound. Okay. Let's see where did it go. Yeah, this. I got this from some of my friends in computer science. There's a job candidate coming in tomorrow named Brian Borowski, and this is actually very closely related to some of the stuff that we're talking about in this class. Okay, interdisciplinary research is becoming more prevalent. This is tomorrow. Okay, let me throw this Zoom link into the chat. I am not so decrepit that I can't do that. Okay, if you're interested, take a look at that. Okay, and see what you want to do. Okay, the other thing that I wanted to tell you about is something going on at the LenFest Center. And I'm not sure where. I'm gonna email you both of these things so you got in your email later tonight. But there's a big installation being set up. The LenFest Center is the big new art center that's across the street from the Computer Music Center at West 125th Street, and this thing is calling "Hearing Sounds Underwater." And it's an art installation by a pretty well-known sound artist, and it should be really intriguing. If you're interested, you'll get the information. It's going up next week, and it'll be up there for 2 weeks for people to see. So yeah, be on the lookout. I'll be sending you that stuff. Okay. Hey, we're over time. Thanks for hanging with me. Get one new message. Yeah. Okay, everyone. Hope that was okay. Like I said, I hope for the CS folks it wasn't too boring. I hope for the non-CS folks it wasn't too horrifying. Yeah, like I said, reach out to me and Nicola if you've got some questions, and everything should be okay. And next time we'll do some more of this, but it'll be more focused in on actual data sonification. So yeah. And the other things, bear in mind, this is the first thing. You're being thrown in. Some of this is going to be redundant. We're going to be looking at the same parameters and stuff like that. We're just going to be feeding them different ways. So be prepared. All right, everyone. That's it. See you all. Be careful in the snow this weekend, and see you next week. Yeah, Nicole and I are going to hang out for a second. So
Thanks, Brad.
all right, see you, Vinny.